Welcome to section 3.6, modeling direct variation. Now, direct variation is a really good form of modeling and something that is easily understood in math. Direct variation essentially says the more of as one thing goes up, the other thing goes up. As temperatures increase, the amount of ice cream eaten increases. As more people are playing video games, the more streams of those video games exist online. Those are just a couple things that could potentially work for direct variation. The equation for direct variation is just this, y equals ax. And the important thing with this is that a is what's called the constant of variation. That's what affects how much these end up varying. So one thing we'll have to do is identify if something is direct variation. So we need to rewrite these equations to see, can they fit the form y equals ax? Well, first thing with this one, let me double check what this is supposed to be here, because it's supposed to be 2x minus 3y. So let me just quickly fix that y so it actually looks like a y and make this x an x so we can tell what it's supposed to be. So I need to solve for y essentially because we need to get y by itself. Well, let's change this to a plus negative 3, and then we can subtract 2x from both sides. So we'll have negative 3y equals negative 2x. We can now divide both sides by negative 3, and are left with a y equals 2/3 x. That is direct variation, and our constant of variation is going to equal 2/3, because that's what's multiplied by x at the end. Let's try this next one. Negative x plus y equals 4. Well, we need to get y by itself, so we'll add x to both sides, and we'll come out with a y equals 4 plus x. Well, it's not 4 times x, and this specifically has to be multiplication, so that is not direct variation. Now, when we graph direct variation, it's actually really nice because there's no y-intercept. There's a plus 0, but plus 0 doesn't actually change anything, so it's just sort of hidden in there. So with direct variation, you are always guaranteed to have it go through the origin. Now, from this point, all you need to do is find the next point, which you can do by using the slope. So in this case, we go up to right 3. So we've got our next point. You can go ahead, connect the dots, draw your line. That's all there is to it. So for this next one, you've got your point at the origin. You would go down 3. And remember, if there's nothing under that 3, you still have to go over 1. And connect the dots, draw your line. Also, just as a reference when you are drawing things, whoops, come on. Oh, sorry about that. That was suddenly doing really strange things on my tablet. Remember, when you're graphing a negative slope, it should be decreasing as you read it from left to right. If it's a positive slope, it would be increasing from left to right. And so since this is a negative slope, it's going down as you read from left to right, so it works out. Something else you might be asked to do is figure out what is the direct variation equation. Well, remember, it's y equals ax plus b, but that b is 0 because it goes through the y-intercept, or through the origin, so that doesn't actually affect anything. Well, that a is still the same spot as the m, so it's actually the same in this case as the slope. So all you need to do is figure out what's the slope, and now you can write the equation. Well, the slope says we go down 2 and right 1. So we'd go down 2, right 1. That gives us a slope of negative 2. So our equation is just going to be y equals negative 2x. Direct variation equations are also really helpful for solving various actual real-world problems. So one of these problems is trying to figure out how much salt do you need to add to your saltwater aquarium. So this problem goes, a number s of tablespoons of sea salt is needed in a saltwater fish tank, and that number varies directly with the number W of gallons of water in the tank. A pet shop owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank. Write a direct variation equation of W and S. Well, what we know is that our amount of salt varies with our amount of water. So salt, water. The amount of salt was 100. That equals A times W, and the amount of water was 20 gallons. So we can go ahead and solve for A, which will give us a total of 5 for A. So now our direct variation equation, just S equals 5W. And that's all there is to it. If you have a 100-gallon tank, you now put 100 in for W, and you know how much salt to add. If you have a 10,000-gallon tank, you put that in for W, solve for S. One final question here is back in the day before Spotify, which hard to believe that exists now, but back then you actually had to purchase your songs and buy them, and you could buy them either on a full album or individually as an individual song here or there on iTunes. Now, that's the era that this question is from. So this is a table showing the number of songs that you buy and the total cost to you. The question is this a direct variation equation? Well, if you think about it logically, how much does it cost you to buy 0 things? Well, if it costs 0 thing, or if you're buying 0 things, that should cost $0. So ideally, there would also be a point that says at 0 songs, it costs us $0. So now all we need to make sure is just that the slope remains constant. So what we need to do is just see what is the slope going from 5 to 3 and from 7 back to 5. So we can go and do 495 minus 297 over 2 and see, does that equal 673 minus 495 also over 2? Well, in this case, it does. That both of those actually come out to be 99 cents. So it costs 99 cents a song, which used to be the going rate of a song on iTunes. So this does vary directly as S. We have our slope for that constant of variation. So our equation is just the cost is equal to our slope times the number of songs. So that's all the more there is to it for this section. So good luck, and as always, shoot me an email if you have any questions.